Hello everyone, welcome to my YouTube channel. So here today we are going to be looking at computer hardware, memory and system performance. We are going to be looking at these questions. So the first question says, John Doe is building a new computer for home use, light gaming and video streaming. He wants a system that runs without lag, can store his files and media, and can handle occasional graphics intensive tasks. So the first question says, what speed should John target for a processor to ensure smooth performance for his tasks? So for this question, what John should target is a processor with a speed of 3 gigahertz. So we know to say from physics, giga means 10 to the power 9. So this is a billion. So he needs a computer that can be able to execute about 3 billion instructions per second. So this computer will help him to for there to be a smooth performance without any lag. A lag simply means to say it's more like it's pausing at instances. Now we don't want that, so we need a processor speed with about 3 gigahertz of speed. Then this one says, how much RAM should John include in his computer to handle multiple applications running at the same time? So the requirements for this is you can give a range from 8 GB of RAM to somewhere 16 GB of RAM. So this RAM will help him be able to execute tasks without causing the computer to lag. Remember, the working of the RAM, it also helps perform many instructions for background information. So we are here now. What SSD storage capacity should or would be reasonable for John to store his documents, media, files and games? So we know that the games are very, very much big. So we might look at something like 512 GB, at least to 1 TB of space. So this space will allow him to be able to store his document, his media, files and even games. So with this space, it is sufficient to be able to store those amounts. Then when we are here, what size would be the graphics card be to support is light gaming and the video streaming? So light games, you can just use a 2 GB or a 4 GB graphics processing unit or graphics card. So now what this does is that when let's say you're playing a very big game, let's imagine that this is a game like that. Then in a game, there is a person here. Then what the graphics card does is that it will be able to more like influence all the things that are around the person. Let's say this thing, it will be able to tell the color of this thing. At the same time, it will be able to coordinate the movement. It will be able to, let's say, if this is the playable character, we also have, let's say, if the car is moving, if let's say a car is moving in this direction, then it will be able to move. Even the color it will have the color of the sky and all that. So there will be a lot of things. So this is required to be able to be performed at the same time. So now what you need for this is a graphics card. So if you have about a 2 GB to 4 GB graphics card, it can be able to perform such tasks. So the bigger the graphics cards, the more smoother, let's say, a game will be able to run. Now we have chosen about 2 GB to 4 GB because it's just light gaming. If it was heavy gaming, we could have looked at something such as a 4 GB to somewhere 6 GB to be able to handle such a task. Now when we are looking at what monitor resolution should John choose for comfortable viewing during work and entertainment? So for many of you that watch movies, the best quality that you know is 1080. But to write the full resolution, we are going to have it is 1920 by 1080 pixels. So this is the resolution that the person needs. So this resolution is very good as it shows very clear camera, or rather the videos are very clear. So this is an example of a 1080. So as you can see, this animation is really good as compared to these other resolutions. So this is our 1080 there, which is very clear, and it is good for entertainment. Most of the devices will be able to support 1080. Not all of them will be able to support 4K like that. So we are going, this person for entertainment, they can use this 1080 pixels like that. So as you can see, even the quality, even here, as you can see, this is blurred, but the 1080 is very clear like that. So that is what John can use. So for this other one, we are told also answer the following questions that will help demonstrate your knowledge of how the computer works. So the first one says, what do you call the process by which the CPU fetches? Number one, the CPU fetches, decodes, and executes instruction. So this is what we call instruction cycle. So instruction cycle is the process by which the CPU is able to fetch the information, it is able to decode, meaning to deduce the meaning, and execute to produce an action. Then this one, it says, what do you call the memory that appears to the computer as extra RAM but is actually stored on the hard disk? So this type of memory is what we call virtual random access memory, which is random access memory, which is virtual RAM. So this virtual RAM is stored in what we call the hard disk. So this is the working principle of RAM. Like for example, if you are looking at you want something in a small room, it will be very easy for you to go inside. Let's say if this thing is blue, it will be easy for you to go inside and look for that thing. You will be able to enter and look for that thing. So that is RAM. So RAM is small. You can have RAM such as 8 GB. You can have RAM such as 16 GB, sometimes 2 GB, and all that. Now, when we are looking at the hard disk, the hard disk can be as large as so if we were to compare it with RAM, let me reduce this. So RAM might be like that, then the hard disk might be like that. So now the hard disk, let's say it has got components, or rather rooms. So you are told to look for something in a room. It will be very difficult for you. Let's say it's here. Now you don't know, you are coming from here. You enter this room, you go like that, you go like that, you enter. All this, you cannot find it until you go there. So this is the working principle. So when things are stored in RAM, they can easily be able to be retrieved or found. In other words, when they are found, they are able to, more like when they are found, they are able to be executed in good time and to produce a reasonable action at that time. Now the pressure with this one is because it's big, you will find that it will be very difficult for you to find the information. Now, why is it used? Like for example, if you have a computer such as 4 GB, now you are trying to play a game that is let's say 7 GB. RAM is the one that more like helps with that. But if you want to play with 7 GB, what will happen is that the computer will now add some RAM from it will add some RAM from the hard drive so that it can combine to accommodate that. It will be a 4 plus 3 GB, which will accommodate the 7 GB to be able to play that game. So that is the RAM. So it is a smaller, or it is a slower in terms of processing. The CPU with multiple processing units that can execute instructions simultaneously is called. So this one, multiple processing units. So already that's the key. You just write multiple core. So this is a multiple core processor is already there. So the multiple core processor is able to simultaneously perform multiple processing units. So you can think of it like this. Let's say we have the road like that, then we have cars that are moving. Let me use boxes. So we have cars that are moving like that. So in one lane they are able to move like that. But when we have multiple cores, it simply means to say, for this one the cars will take long to reach. But if we have multiple cores, we simply mean to say we have multiple lanes in which the cars can be able to move, thereby doing things at a very, very faster rate. So multiple cores are able to produce or perform multiple tasks at the same time, which reduces the rate at which work is done. So for that one, that's the multiple core. Then when we look at this, the non-volatile, or the type of memory that is non-volatile and stores firmware is, for this one, the memory. When you're looking at memory, you're looking at RAM and ROM. So this one is read only memory, which is what we are going to call ROM. So ROM is non-volatile, meaning to say when you switch off the computer, it does not disappear, or rather, or lose its content. So the example that we can have is the BIOS, which is the basic input output system operation. So just as I've said, basic input output system. So this is very, very important, because this is the one that leads to the, let's say, the computer to know how to turn itself on. Now if this information is constantly lost, you will find that the computer will not be able to turn on. So it has to be non-volatile. So the firmware that we might be talking about, this is an example of the firmware that we are talking about, BIOS, basic input output system. So this one is able to allow or make sure that the computer is able to turn on when it is supposed to turn on. When you turn on your computer always knows how to turn itself on. For this other one, a memory that sits between the RAM and CPU to improve speed is called. So for this one, the memory type that sits between that is what we call cache. So this cache sits between the CPU and the RAM. So going back to our same ideology, we have the cache is used to access frequently accessed information. Like for example, when you download Facebook, you might be able to download the Facebook, let's say at 9 MB. So this 9 MB is the starting, but as you use it, you will find that Facebook might be as large as sometimes even 800 GB, but it was just 3 GB. Now this is as a result of accumulation of, number one, cache, and also other information. Okay. So now other information, like for example, if you are switching on Facebook for the very first time, you are required to log in. So you are required to log in and put all your credentials. But with time, due to cache, you will find that immediately you just switch it on, you put it in, you just find the message box. You don't have to log in. So that is one of the examples of the working of cache. It helps increase access time for frequently accessed documents or apps. So now this one, cache memory is usually smaller than RAM. So like for example, we might have the RAM and it is found inside, it is found in between there. So let's say we have our cache there, let's say we have the CPU there, then let's say we have the RAM. So the RAM is big, meaning to say the same ideology still works. It will be difficult, but if the information is frequently accessed, that information is now stored in cache so that it is easily accessed like that. So the RAM is the one that sits between the two, which is the RAM and the CPU. Thank you very much for watching. Hope you would like, subscribe and share for more. See you in the next tutorial.